This is Unit 6.3. We're going to look at some polynomials today. So our objective is defining a polynomial. We're going to classify a polynomial as either a monomial, a binomial, a trinomial, or a polynomial with more than 3 terms. We're going to evaluate a polynomial for given terms in the variable. All right, so one thing you need to know about what is a polynomial. It can be one term. Now remember, terms are separated by plus or minus signs. So I could have 3x, which is one term. 2y is a second term. And the number 3 is a third term. And those 3 terms are separated by the plus and minus signs. All right, so a polynomial is one or more terms. So if you have a number times a variable raised to an exponent, it's a term as long as k is a real number. And in this course, we're only dealing with real numbers. And the exponent has to be a whole number, okay? So if you end up with something like 4x raised to the 1/2, 1/2 is not a whole number, and so that would not be considered a polynomial. So even if you have a whole number by itself, like the number -3, could we write -3 with an exponent? Yes, we could, because remember the exponent of 0, or not 0, that would be the number 1. If I raise -3 to the first power, that is that has a positive whole number exponent, so that would be considered a polynomial. Okay, so if you have only one term, it's called a monomial. For example, 5x raised to the third is a monomial. The degree of the term, so they're going to ask you the largest degree. Well, the degree of a term is 3. So when it's asking you the degree of a term, it's asking you what the exponent is. And the coefficient of this term is 5. Okay, so the degree of this term is 3 because that's what the exponent is. And the coefficient of this term is 5. So a polynomial is a monomial or the indicated sum or difference of monomials. In other words, if it has more than one term, then it's still a polynomial. The degree of a polynomial is the largest of the degrees of the term. In other words, the largest exponent. And the coefficient of the term of the largest degree is called the leading coefficient. So we will look at examples like that. I know right now that's a little unclear. So let's look at some examples of polynomials. So a monomial is a polynomial with one term. For example, this is one term. That's a monomial. This is one term, so this is another example of a monomial. A binomial is a polynomial with 2 terms like this. So this has 2 terms. 5 is a term, 3x is a term. They're separated by a plus symbol. So this is a binomial, like a bicycle, 2 tires. Bi means 2. This is another example of a binomial because it has 2 terms. And of course, trinomial, like a tricycle has 3 wheels. A trinomial is a polynomial with 3 terms. So we have 1, 2, 3 terms. So x squared, 6x, and -7 are our 3 terms. So that's a trinomial. A raised to the third power, -8a squared is the second term, and positive 12a is the third term. This is also a trinomial. Now you can have polynomials with more than 3 terms, but we're just going to stop. We're not going to go past trinomial. You would just identify it as a polynomial. Okay, so there are terms for those as they get higher, but we're not worried about that. So we're going to simplify each of the following polynomials by combining like terms. We're going to write the polynomial in descending order according to their exponents, and we're going to state the degree and the type of the polynomial. So, letter A. Since the exponents and the variables are exactly the same, then that means those two terms are like terms, and so we can add the coefficients. So only when the variables and the exponents match exactly can you add the coefficients. So 5x cubed plus 7x cubed equals 12x cubed. So we've simplified it. We're going to identify it as a monomial. And it says to state the degree. The degree is 3 because that is the exponent. And we said what type is it? It is a monomial because it's only one term, because you could combine those two terms to make one term. All right, letter B. We have two like terms, x to the third, x to the third. So here we get to combine those two coefficients. So it's 12 x to the third, and then minus 2x doesn't have a like term, so that's part of our answer. So since there's two terms, it's a binomial. Now the way you're going to write them is you're going to always list them from the biggest exponent down. So this exponent is a 1. So since 3 is bigger than 1, 3 comes first, or this whole term comes first. So that's what it means by descending order. So this is written in descending order. It says to state the degree of this binomial. The degree is 3 because that's the biggest exponent. And normally it would also ask us what is the leading coefficient. Well, the leading coefficient with the biggest exponent is 12. And we'll get into some examples like that. All right, letter C. Do we have any like terms? Well, we do. So this has y to the first, and this term has y to the first, which means that these two terms are like each other. So we can add 3 plus 1/2. But the directions say to list these in descending order. So since the exponent of 2 is bigger than the exponent of 1, when we write it in descending order, we're going to write negative 2/3 y squared. That's our biggest exponent. We're going to combine these two terms. So 3 plus 1/2 is 3 1/2. Y, remember our exponent is 1. This one has the biggest exponent, so it comes first. And then we're going to write all constants at the end. So we have written that in descending order. It wanted us to describe the type. So there's 3 terms. So this is a trinomial. Our degree of this trinomial is 2 because that's our biggest exponent. And the leading coefficient is negative 2/3 because that's the first one that's in order according to the exponents. So the leading coefficient is negative 2/3. All right, letter D, we're going to combine our like terms. So x squared and negative x squared. So 1 plus negative 1. Basically, these two cancel themselves out because x squared minus x squared is 0. 1 minus 1 is nothing. So all we have left is 8x minus 15. So we put those in descending order because this exponent is a 1. The only thing we could have here, this is a constant. This doesn't have a variable. All right, so our polynomial is a binomial. The degree is 1 because that's our leading coefficient, our leading exponent. And then if it asks for the leading coefficient, the answer would be 8. Letter E, we're going to combine like terms. So this is, first of all, I noticed that this has a negative 1 in it. If any of your variables is raised to a negative exponent, that means it's not a polynomial. Because on that first slide I showed you, our exponents had to be whole numbers. So we're done with this problem. It's not a polynomial. All right, letter A. This time it gives us a trinomial, but it tells us to solve for P of X is equal to this trinomial, but then it says they want you to use X equals 3. So the way that would be written is they would say solve P of 3. So see how if those directions continued, see how 3 is in the place of X? That just means that they want us to replace all the X's with a 3. So we're going to write it. Make sure you always write with those parentheses, whatever you're substituting. Plus 5 times 3 minus 15. So always do exponents first. So 3 squared. This isn't 12 squared. It's only 3 squared. So 3 squared is 9. So it's going to be 4 times 9. 5 times 3 is 15 minus 15. 4 times 9 is 36. Well, 15 minus 15 is 0. So our final answer is 36.